All right, let's go ahead and begin. Thank you everyone for joining us for this live presentation for Balluff's automation launch. My name is Chris Duncan. I am the trade show and event specialist for Balluff, and I will be your host for today's live presentation. I'd like to take a moment to remind everybody that after this presentation, please explore Balluff's automation launch virtual exhibition room to learn more about the latest manufacturing technology that will make sure that you are prepared for 2021. And be sure to chat with our Balluff experts about any questions that you may have. Before we get going, there are just a few housekeeping items I'm going to review to enhance everyone's experience. First off, for the best viewing experience, we recommend closing any extra programs or browser sessions running in the background that could cause any issues. Streaming live presentations is bandwidth intensive, so closing any unnecessary browser tabs will help conserve your bandwidth. For those of you watching this presentation live, if you have any questions throughout the webinar, please submit them using the Q&A chat box. I will gather all the questions throughout the presentation, and there will be a Q&A session at the end of the presentation. We will try to answer all of the questions during the presentation, during the Q&A session, but if a fuller answer is needed, or if we run out of time, it will be answered later via email. Please know that we do capture all questions. And if you think of a question after the presentation ends, please visit the virtual exhibition room and connect with our Balluff experts, and they will be sure to answer your questions. For those of you watching this in the future, please use the Contact Me After This Event button inside the virtual exhibitions and send us an email with your question. A copy of these presentation slides are available in the box.com link that I put into the Q&A chat box. And an on-demand replay of this presentation will be available after this presentation in the same location on the virtual platform that you saw this one. Our presenter today is Greg Molinaro. Greg Molinaro is Balluff's Packaging, Food and Beverage Industry Manager for the Americas. Greg is enthusiastic about smart manufacturing, predictive maintenance, and the creative application of IO-Link in manufacturing automation. Greg graduated from Purdue University with a degree in electrical engineering, and he has been sharing his passion for automation for 25 years in a variety of industries. He has designed control systems, consulted on network architectures, wireless, inventory and warehouse management, RFID, barcode, sales process, and production process improvement. Without further ado, I'd like to present Greg Molinaro and the Smart Automation and Monitoring System for the Smart Factory and Smart Machine.
Oh, thank you, Chris. Welcome, everyone. Good afternoon. So, as Chris mentioned, I'd like to talk today about smart factory and smart machine concepts that are available today. And what we're going to do then is talk about some of the application areas to consider, and then we'll go into what the smart automation and monitoring system is, what some features are relating to the system, the devices, and what makes up that system. So looking forward to presenting the material today. So first off, what I thought would be really good to talk about is when you're considering packaging food and beverage, and quite frankly, pretty much any manufacturing industry or segment, there are some primary areas of application or application areas that are prevalent. And we're going to talk about three primary ones: controls architecture, format change, and predictive maintenance. But there's also level monitoring, robotics automation, and quality assurance that are important and part of the smart factory, but we're going to focus on just a few of these today. And I'd like to start off by talking about controls architecture, because when you consider controls architecture with IO-Link, now you're talking about the backbone of the smart factory and the smart machine. And that's really critical. So understanding, IO-Link and the advantages of IO-Link from a controls architecture perspective really helps in being able to then take smart devices and other smart factory concepts and implement them. And why is it that IO-Link is is important and is the backbone? Well, a huge part of it is the fact that you have process data, you have configuration data, and you have diagnostics data available and separate so that it doesn't interfere with the PLC and the processing. And also a big factor, which we'll talk about quite a bit later in the second half of the presentation, is diagnostics and having enhanced diagnostics. But in particular, being able to connect smart devices is really what IO-Link is all about. The thing also that's exciting about IO-Link when you look at the perspective of the smart factory is the ability to easily retrofit and upgrade your existing system to be able to get the enhanced troubleshooting and diagnostics and the smart factory concepts. So being able to distribute your IO, to be able to detect different positions of, say, valves, or for being able to, more easily troubleshoot because you don't have to fish through the wiring. You're dealing with port level diagnostics right to a device, and being able to have better guidance regarding maintenance. And so here's an example of upgrading controls in a dairy plant, and it was significantly easier and reduced time to install because you're dealing with quick disconnect and plug and play. And then when you were talking about the smart machine, same concept when we're talking about IO-Link, being able to incorporate the controls architecture of IO-Link easily and quickly. And there are some other benefits from a machine building perspective, is that you reduce the wiring. So being able to reduce the number of wires or cables going back to the control panel, being able to make your system more modular, and really being able to build up the machine to the Industry 4.0 or IIoT level, because of being able to incorporate smart devices that have your diagnostics and other information to make it more available from a predictive maintenance perspective and from a servicing perspective. So that's the application area called controls architecture, which leads us to guided format change. And that was why I felt it was important to talk about controls architecture, because in order to take advantage of smart devices to help guide operators to do changeover, you're going to want to have or need to have the IO-Link controls architecture backbone in place to be able to primarily take advantage of configuration, or being able to change the configuration automatically, or what we call parameterization. And so when we're talking about guided format change, we're talking about putting the sensors on a machine like a cartoner that can run multiple different carton sizes. Well, when you change from a smaller carton size to a larger carton size, there could be anywhere from 15 to 60 plus different positions on the machine that need to be adjusted, or change points that need to be adjusted. So what's great about guided format change with IO-Link and smart devices is that you send the parameter to the device. There's no guesswork in, is it the correct position, and did the operator move or adjust things correctly? And more importantly, after the adjustments are made, you're not having to do tweaking and adjusting, which could go on for an entire shift or more, depending on how involved the adjustments are. And so we've been able to implement this and, and seen in some cases a reduction of up to 65% of the time that it takes to do the changeover prior to implementing the guided format change. Another aspect to format change that's part of guided format change is change part identification. So if you have a part that you need to swap out of the machine when you make the adjustment from the smaller box size to the larger box size, as an example, you want to make sure that the correct part is put in. So you can put an RFID tag on the part, you put the read head, the RFID reader on the machine, and now you know that, hey, is this the correct part or not? And so you won't start to run or continue in the changeover or in production with the wrong item. So you're really eliminating these errors and the possibility of crashing the machine. It also saves time. And BALF, when you're talking about IO-Link, we've been in the market with IO-Link. We helped present that to the market about 15 years ago and have been a market leader and have been providing and been a leader in industrial RFID since the early 1980s. And here's an example just showing a couple of different ways to implement RFID with tags and a reader. So on the left, you'll see the red circle on the top is a reader, and down below are 3 different tags. So in this case, the one reader is able to pick up the 3 different tags to make sure that all the different parts of that section of the machine have been changed. And then on the right side is we're looking at a single barrel style RFID read head that will then read a little bit more close proximity device or part or a single tag. Then the next application that I'd like to talk about is called predictive maintenance. And IO-Link, smart devices, that's what predictive maintenance is all about. So being able to enable or implement bidirectional communication sensors that can provide various types of diagnostic and event data or condition monitoring parameters and data. So examples of that type of information would be temperature, vibration, humidity, pressure, inclination, life of the number of hours that the device has been used, and then really being able to take advantage of adjusting change or set points and being able to then do automatic field replacement. And what does that mean? What we're talking about there is being able to recognize before a device is about to fail and have the configuration set in the PLC or in the IO-Link master block. And when you plug that device in, it automatically gets the proper configuration, and you don't have to do that manually on the floor or try to have it done ahead of time. And so what we're talking about with IO-Link and smart devices regarding condition monitoring is considering the health of the device and also the health of the machine. And we'll go into a lot more detail about this subject in the second half of the presentation. And here's an example of implementing IO-Link. And again, IO-Link controls architecture being the backbone so that you can take advantage of all of the smart devices. An ice cream manufacturer retrofitted their production line with the BALF IO-Link master blocks and hubs on their controls architecture or their network, and then they were able to then pull all of that information onto their SCADA system. In fact, even using the actual images of the blocks, and then are able to do configuration and changes on the fly, but also being able to remotely monitor and see all of the information real time. The last area that I'd like to talk about regarding application areas is quality assurance, and in particular, talking about traceability, tracing, and tracking with RFID. So what you're seeing here on the left is filling of a bottle in a tote or in some type of a tray, and being able to put a tag on that so that as it goes through doing work in process, you're able to identify that workstation and verify that the previous work had been done, what needs to be done in that particular step. And then also, one other really interesting area is being able to take and if you have bins, like in this case, we're looking at bins of coffee, and being able to make sure that it was where it's supposed to be in storage, but then when it gets moved and put into production, that it's the correct recipe or blend, or it's the correct product for that particular production application. And so I wanted to give an example here also of error proofing. So quality assurance, we're talking about traceability with RFID, and then we're also talking about error proofing with vision inspection. One of the major areas of error proofing that we can help with is date code verification. So if you have your production date code, on the bottom of a can or on the side of a plastic or glass bottle or on a package, and you want to make sure that the code wasn't damaged, that it wasn't missing, or that it was correct, being able to use vision inspection to verify that that code is there is something that we do all the time. It's a very straightforward application, and depending on your customer, sometimes it can be a big problem or a big challenge if a whole load or a whole order goes out, or there's intermittent missing of codes, and then that whole order has to come back. And so being able to help catch that early enough or at the beginning of that production can really help quite a bit. And so, being able to do a variety of different error proofing applications with bottling, checking to make sure that the caps are there, not there, the correct bottle, the correct fill level, even color grading and sorting. So a number of different ways that we can help with error proofing and help incorporate that into the smart factory, and in a number of cases with IO-Link. And in conjunction with that, having a really straightforward, easy to use graphical user interface via web browser that's the same for all the varieties of vision inspection that we can provide. And here's an example of that user interface, just showing an example on the bottom of a can to make sure that the ovality or that the can isn't warped on the bottom. And then on the bottom image there, showing the date code, and that we're able to identify it, pick it up with the camera and identify it and verify that it was correct. So now that we've talked about the application areas to give you an overview of where you can implement the smart factory and smart machine concepts, I'd like to start here the second half of the presentation, talk about what the smart automation monitoring system is, or what we call SAMs, and how that plays into the smart factory. And to really help understand where this came from, wanted to start off by talking about what SAMs is really addressing when it comes to the into production, in particular the areas of efficiency. And so how did we come up with this? About 4 or 5 years ago, we had put together what we called a think tank, and had about 15 or 16 people that were part of the global team that interviewed around the world various customers, various production food and beverage producers, and asked them what were the primary issues that were causing them trouble. And what we came away with is, across the board, the issue of efficiency was the main topic. In particular, unplanned downtime, and then also planned downtime from changeover, but also what can happen with the extreme washdown environment and the failure rates of components due to that harsh environment, along with not having necessarily a straightforward way of managing a device or a consistent way of managing it from a configuration or a status perspective. And so what we determined were the desires of customers in the food and beverage space is being able to have longer lasting devices for the washdown environment, and being able to have more flexibility by having more straightforward parameterization, configuration, and diagnostics, so like a common look and feel, and then having devices that can do more than one function, or being multifunctionality. And I'll talk more about this here as we go. And just to kind of make sure, when we're talking about OEE, I like to mention what we're referencing so that we're all on the same page. But when we're talking about OEE, we're talking about availability loss. So your stops and slows. We're talking about, downtime. We're talking about unplanned and planned downtime. We're talking about performance loss, which is your stops and slows, or not running at the full speed that the machine should be able to run at, or the line. And then your quality loss, which is the waste that can happen from when you start the machine up, or when you have defects or errors or product that you have to kick out because it wasn't produced properly. So when we're talking about OEE, this is what we're talking about. And as we go through the presentation, you can think with, or we'll talk about how the SAMS product and the SAMS family helps directly impact and improve OEE. So what are we talking about when we talk about a system? What we're talking about is a combination of interrelated and interacting devices or components that form one entity, as a formal definition. From a BALF point of view, what SAMS is it's a combination of the software and the devices, in this case sensors, that are being used to implement condition monitoring and implement the advanced IO-Link feature set. And by doing so, it helps and will eliminate downtime and simplify troubleshooting, changeover, and machine setup. So when we're talking about a system, we're talking about the software in combination with the devices or the sensors. And so what are some of the components that make up the system? Right now, these devices will start to become available at the end of this month. And to start off with, you'll see inductive, photoelectric, and capacitive sensors, along with RFID read and write heads, master blocks and hubs for the controls architecture, and then the software, which we're calling a BALF engineering tool, which is what is used to help do the configuring and monitoring of the system. As we move forward with our product development and releasing more and more devices, you will see pretty much anything and everything that we come out with will have this common look and feel and feature set. And so the idea here is to really be able to provide as all this information and event data that's possibly available directly for helping with your production floor reporting. And so overall, the idea is to be able to help reduce the planned and unplanned downtime, reduce the waste, increase the availability and productivity of the equipment, and also make it more straightforward and take less time to train and learn how to work with and use the devices. And you'll see, hopefully you'll see why as we continue. So when you look at the SAMS family, there's 5 main areas or key factors that make up the system. The first is what we call our Washdown Plus promise, which is an enhanced IP69K housing, which I'll explain in a minute. When we look at food safety, we're talking about being able to provide more hygienic options for the market. The third area is having a common look and feel. So we'll be talking about configuration there. And then having smart features or the health of the device, so condition monitoring, and then device status. And I'll go into each of these in a little more detail. So the first challenge or key area that I'd like to discuss is the harsh cleaning environment or process. And so I think everybody that has this type of an environment is very familiar with the potential for the high failure rate of components and unexpected failure and the cost of that to do the replacement, not only for replacing the device, but also the cost of the downtime. And so the way that we're going to help address this as part of the SAMS family is with our Washdown Plus promise. And what that means is we went and identified what the worst case cleaning procedures were based on temperature, time, pressure, cleaning products used, and so forth, and said, hey, that's the benchmark. And then what's the most number of times that a facility would do that cleaning process? And it could be as many as 3 times a day. And so we said, that's our benchmark. We took the existing IP69K rating as the base and then added all of these other factors that I just described, and then came up with what we call the Washdown Plus. So it's this enhanced IP69K rating. And what does that mean? It means that the device is designed and guaranteed to withstand a minimum of 1,000 wash cycles. And so if your cleaning cycle is 3 times a day, the device is designed to last a year. If it's once a day, it's designed to last 3 years at a minimum. So now addressing being able to last longer. And then you'll see also, as we talk about the feature set, being able to identify or predict when or before the device would fail, so you can replace it on your time, not when it decides to fail on its own. So the next challenge that I'd like to talk about, or key factor, is the situation of having an inconsistent look and feel. And what I mean by that is every device having a different way that it's configured, or every device having different mapping or addressing back to the PLC, or different parameters and functionality, even within the same vendor of sensors. And also the need for flexibility of equipment with regards to format change and being able to run smaller batch sizes. So coming back to what I talked about earlier, changeover or format change. And so being able to make that more consistent and have that look and feel the same for those aspects of production. And what are we talking about? Well, what we're talking about is having a consistent and a common form factor for the housing and connectors of all these SAMS devices. So now you're not having to deal with multiple different, like a different form factor for every device. But more importantly, what I think is really interesting is having this consistent and common configuration. So if you understand or learn how to configure a proximity sensor, the way that that's configured and then addressed back at the PLC, and what parameters are available or on that device will be the same for a proximity sensor, for a photoelectric, for a capacitive, for all of the devices. And then in addition to that, being able to have this common look and feel with regards to changeover and being able to more easily and efficiently be able to do changeover because of being able to send configuration changes. And also I'll be showing or unveiling here a new device specifically for changeover, which is the digital position indicator. And so what we're talking about with this device, the digital position indicator, is an IP69K housing and a device that will go right in line with the shaft of a hand crank, and all of these devices are IO-Link. They all, like I said, they all have the same condition monitoring parameters and advanced functionality. In particular, what the primary sensing function of this device is being able to sense or determine the position of that hand crank or that shaft. And what we have here is an LED display, and you can see that there's two numbers. So you'll have the position that you're in displayed, and then when the configuration change comes from the PLC through the IO-Link controls architecture, it'll show then what position we need to go to. And you see these green lines around the outside. Those are actually LEDs around the edge of the face, and they will rotate in the direction that the operator needs to turn the hand crank and then indicate to them when they've achieved the new position. So being able to do guided format change quickly and easily, having consistent and accurate changeover every time, and being able to reduce that time all plays into the common look and feel and helping to improve and reduce the planned downtime of changeover. The next area that I'd like to talk about is what we call missing machine data. And so, not being able to, provide or have these functionalities that you need. And so, it takes longer to troubleshoot. So what was the status of the machine, or what was the condition monitoring? Is it about ready to fail, or is there a change in the environment somehow that could be causing a problem in that area to go look at? And so by being able to have more functionality from the device, more data from the device, being able to really implement condition monitoring consistently throughout the entire system, now we're able to help reduce the troubleshooting time and really implement predictive maintenance. And so what are we talking about? We're talking about the health of the device and the health of the machine, and being able to do that in a couple different ways, starting with having condition monitoring functionality or parameters in each device, such as temperature, vibration, inclination, humidity, signal quality. These will all of these condition monitoring parameters will be available in all the devices and are all, like I said, configured, addressed, etc., the same. And so now you have the primary sensing function of the device, which could be object detection or proximity or position, and you have these condition monitoring values as a secondary function. And so now you really have data sources of the performance of the machine through these devices. Also, when we're talking about this, we're talking about additional functionality. So there's this a ping function in every device, just like when your computer is on a network, and it helps to identify irregularities in communication, or where is the device there, is it communicating, and being able to have that reported, and then having additional smart features such as operating hours at the port level on a master block or a hub, integrated counting, boot cycle, and logic built into the device, which I'll talk about in a second. All of this adding up to helping reduce the cost and time of troubleshooting. And again, really being able to implement predictive maintenance. So when I'm talking about logic in the device, what I'm talking about is, in this example, is of a vertical form, fill, and seal machine. You see all the red dots here are representing a sensor that's already doing a primary sensing function. But now, being able to configure the device with different logic, such as if the vibration exceeds a certain value, now you can fire pin 2 of the device and send that diagnostic information or event data to the PLC, or you can send your event or diagnostic information to your SCADA system or whatever it might be, and you can configure the devices through the engineering tool or the software tool without having to put the logic in the PLC. So you're just configuring, you're literally checking a box and setting a threshold when you set up the device. And now you're able to put that functionality at the device on the machine and get this information without having to write that extra code. And you can change this on the fly. So if you decide, hey, I want to change the temperature level or the vibration or whatever it is, you can make that adjustment automatically. So earlier I mentioned health of the device and health of the machine. So the SAMS devices that have condition monitoring built into them, along with their primary sensing function, that condition monitoring is, we're talking about the health of the device. When we're talking about health of the machine, we're talking about this device here, which is called the Bailiff Condition Monitoring Sensor, or BCM. And this device is, you can see it here in the bottom right of the screen, is a device that can be easily retrofitted into just about any piece of equipment in the factory. And it can be implemented on just about any machine, for a machine builder. Here we're talking about putting it on motors, servos, gearboxes, on pumps, fans, and in this case, you see it in a control cabinet. So an example for a control cabinet is if you have a heavy washdown environment or a chilled workspace or production area, and you're cleaning with hot water, you can cause there to be condensation inside the cabinet or whatever. And that if it gets to be too high, that obviously can cause a problem. So you can, with this device, monitor vibration, temperature, humidity, or pressure. And it can be done in a continuous monitoring and you're able to determine long-term trends and set thresholds with the tolerances that you feel are appropriate for your production area. So really neat device, really very straightforward to implement and very cost effective. So the last area that I'd like to talk about, the key factor to the SAMS family, is what we call machinery and plant health, or the device status. So being able to have a common look and feel and common status indication of each device across the plant to make it easier to monitor, easier to troubleshoot, easier to replace. So here we're just showing a plant and just kind of showing how from front to back or back to front, having the ability to determine the status, making it easier to manage the machinery and the equipment. And in this case, you're seeing colors that represent the different status. So each device not only will have that same status that you can monitor through the engineering tool or the software, but at the device, there's a single LED, multicolor LED that will flash or will, have a steady state that represents the same status for every device. So your power, a failure, your maintenance, whatever that status might be, it's the same color indication for all the devices. And so what that means is, being able to have a uniform and understanding of messaging and indication everywhere instantly along with the condition monitoring like I talked about. So really being able to have a comprehensive diagnostics that you can visualize, be able to take that information, incorporate it into dashboards or your SCADA system directly, and now really having diagnostic information to be able to put together accurate and meaningful reports and trends for your production facility. And again, really being able to fully implement predictive maintenance. And so in summary, I like this slide because it really shows, taking a section of a production line, multiple machines, and how having all this different information, vibration, humidity, the different alarms that can go to your HMI or to a tablet, or it can go to the cloud or go to your SCADA system and be able to be used for reporting and analysis and diagnostics. Really, I like this because it really shows all this information now that's available from the single device that's already on the machine to do its primary sensing function. And so, hopefully I was able to show today smart factory, smart machine concepts that are available today with the smart automation and monitoring system, or SAMS, and IO-Link, and being able to these concepts that we're talking about that are enabled and available today, such as condition monitoring, more accurate data, enhanced diagnostics, making it simple and straightforward to retrofit, having that logic in the device, and really being able to fully implement predictive maintenance and guided format change. Well, I appreciate it. Thank you. And I'm going to turn things back over to Chris.
Thank you, Greg. So now we're going to have our Q&A session. So Greg, we did get a few questions during the presentation. Great. And I'm just going to go in order here. Let's see. Doug asks, can the new SAMS devices be used with the existing master blocks?
Yes, absolutely. There's no, it's not proprietary. Again, IO-Link is open. What we're doing with the SAMS family is really taking full advantage or fuller advantage of the capabilities of IO-Link. And so we've just opened up more of the technology that's available in IO-Link with the features. And so that's all based on the device. And so, yeah, it'll work with existing or installed, BALF master blocks and hubs that are already being used in your facility.
Okay, thank you. The next question I have is Mitch is asking, what are some examples of how to use the condition monitoring functions?
Well, sure. I mean, it could be a variety of things. What we've been seeing a lot this year, so the device came out at the first quarter this year, and I mean, we've seen them a lot with different vibrations. So, your electric motors anywhere in the facility, your gearboxes. Even recently had an application where there was a generator, and in this case it was a diesel generator, and so they wanted to monitor that for vibration. Your fans, it could be like a really interesting example is in a chiller or cooler for chocolate production. So we're blowing cool air to cool the chocolate. When the in this case, the fan blades can build up with some residue and change the pressure or the balance there. therefore not cooling at the appropriate level. And so monitoring that pressure was a way to manage that. So there's so many different ways that we can implement the device. There's two versions. There's a device that does vibration and temperature, and also the vibration is monitored on all three axes, X, Y, and Z. So you don't have to know which axis the vibration is happening on. And then there's a second version that you can do vibration, temperature, humidity, and pressure.
Thank you, Greg.
Sure.
I'm just going to let everybody know I have one more question here, but if anybody has any other questions, please get those in now in the chat box, and we do have some time for some more, but I'm going to go ahead and ask this one here. Gary is asking, can you explain more about the troubleshooting functions that the SAMS devices can do?
Well, sure. So we can talk about it from an enhanced troubleshooting or diagnostic perspective. So you could take one of the SAMS master blocks or hubs, and at each port, at the port level, we can monitor or provide the information of number of hours that device has been operating. And so you could do a retrofit with just the controls architecture and leave all of your existing standard sensors that are already on the machine operating, and just connect them to the hub or the master block, and now we have port level diagnostics. So if something happens with that device, we know it was this port and it's this device, and so we don't have to fish through, or you don't have to fish through the wire to figure it out. But like I said, also now you're able to look at working hours even of a standard non-smart or a non-IO link device. But then say we are looking at IO link devices, now we have a much wider range of information available to really help predict and determine life expectancy, and if there's some ingress that started to happen, or if something is incorrectly getting beaten up in the process. Well, now we know where that's happening, how often it's happening, and be able to do something about it before it just stops or it causes the machine to stop running inadvertently.
All right, thanks, Greg.
Sure.
Looks
thing.
like that's all of the questions that we have. Let's see here. So if anybody has any further questions, please feel free to connect with our experts that are on the virtual exhibition platform. And also I have up here the contact information for Greg himself, so his email address and LinkedIn URL there. That's what his LinkedIn profile looks like. But yeah, so if you think of any other questions, please feel free to connect with us. And join us in our virtual exhibition room, where we'll have staff on hand to be able to further answer any questions. I just want to say thanks again to Greg Molinaro for sharing this presentation with everyone, and thank you to the viewers for your attention. I hope that you have enjoyed this presentation, and I hope that you're enjoying Balluft's automation launch. I'll leave you with the remaining presentation schedule for the week. Please be sure to come to the other live presentations this week, and please chat with our experts and let us know how we can help you be prepared for 2021. Thank you, everyone.